Welcome to General Structures 2 and Lateral Forces, Lesson 5, Example number 8. And it is asking us to, let me get to it. Actually, it says we have a two-story braced frame and it is subject to the wind loads and dead loads shown on the above right, which is there's a diagram, and I'll draw it up in a second here. It says, what is the overturning moment at the base? So what is the OTM? I'll call it, overturning moment. So that's number one. What is the overturning moment at the base? 2, what is the dead load resisting moment? What is the moment DL resisting? Is what I'll call it. What is that? I'll explain what that is in a moment. 3, does the structure have an adequate factor of safety? We'll say adequate FS. Let's get rid of that. FS. Alright, now let's go ahead and make this diagram. Alright, there we go. And I'm going to oversimplify it. 4 times. But it's got cross bracing like that. And let's go ahead and change colors and go ahead and do the loads here. We have a dead load that equals 25 kips. We have another dead load right here, which is equal to 25 kips. And I'm assuming this is how they're representing the dead load of the members, all the members, and they're just distributing it half here, half there. It's kind of a simple way to look at it, which is fine. And this is 10 kips, and this is a wind load. And here's a wind load, and it's equal to 20 kips. Alright, so there are our loads. First we need to go ahead and find our overturning moment. The overturning moment is, when I say overturning, it means that this is going to overturn. It will want to go like this. When you hit with the, think of a pencil that you're laying on it. If you push it with a lateral force, with a side force, which I'll call lateral force, then it will want to turn over and fall down. Alright, so what I like to do when I'm doing an overturning moment, it's at the base, and you can really think of it like this. Is the overturning moment. And then the resisting moment is just the opposite, is like this. I shouldn't have put that right next to it. Let's see if I can move it over ever so slightly. So what I like to do, I'll change back to green. So we'll call this the OTM, and the pink will be the moment resisting. Let's just call it MR. MR. Alright. So let's go back to green and let's find out what our overturning moment equals. And when I do this, what I like to do is you could sum the moment about this point in the middle, which would mean it's, I didn't put the dimensions on here. Let's go ahead and do that. Here to here is 10 foot. This is 10 foot. So the entire thing is 20 foot, and then between here and here is 20 foot as well. And what I like to do is sum it about this point right here. And the reason I sum it about this point right here is because, as an overturning moment, if you just think about it, let me switch colors here to make it clear. We'll make it yellow. Yellow stands out. Is, at what point do I need to sum this moment to where it would pick up? If I held it right here and pinned it right here and pushed it over here, it's going to want to pick up. Correct? At this point right here. I hope that makes sense. And, if I sum it about this point right here, then that's just going to add to that moment, and it's going to, make a larger reaction right here, but that's okay. So what we're looking at is this point right here. So anything that's going to create uplift, and at any point that's where you want to sum it. So our overturning moment is what it's going to cause the overturning of this building. So what we want to do is do 10 kips, which is right here, times 20 foot up, plus, and this is going the same way, so it adds to it, 20 kips times 10 foot up. And that equals what? 200 plus 200 equals 400 foot kips. And then that is our answer, 400 foot kips for this. So we'll just go ahead and write it down here. 400 foot kips is our overturning moment. Excellent. Step one down. Number 2. What is resisting that? Okay, now if you look at it, what is going to resist that force? Okay, so if we're doing this, we're summing about this point, that is what's bad. So that's our overturning moment. Now what's resisting that overturning moment? Well, this load right here it's concurrent with that point, so it's not going to help us at this point. But this one is 20 foot away, so that's going to be our resisting moment. And you may have additional, dead loads, but just for this, all we have are 4 loads, and this one's concurrent. We've already used those 2; those are bad, so it's going to be, as I say, anything that rotates it this way, and that is what that dead load does. So what we have was 25 kips times 20 foot from the point equals, what is that, 500. And if you don't trust me, get out your calculator and figure it out. 500 foot kips. This math is pretty easy. So that's what your resisting moment. It is resisting the overturning. I think that's pretty self-explanatory, and I'll stop right there. So I'll say 500 foot kips. All right, and last but not least, adequate factor safety. And for lack of a better term, factor safety is what? Oh, I'll say, kind of our capacity. In general, its capacity is how much can you hold over whatever your load is. And in this case, our load is our overturning moment. Our capacity, or the resistance, or sometimes you could just say resistance overload. Let's do that. Resistance. I think I spelled that right. Resistance overload. So we're resisting that load. So our resistance is, if it's lower, then it's not good. And usually you'll have some sort of factor safety. In overturning, most of the time it's going to be 1.5. So that's what we want. We want it to be 1.5 or greater. So let me think. Yeah, we'll say there. Factor safety is greater than 1.5 is what we want. Okay, so let's figure out what we have. Let's go ahead and do this. I'll change colors one more time. We'll do our resistance over our load. We said that the resistance is 500 foot kip. That's our resisting load. Let's say factor safety equals 500 over 400, which is our load, our overturning moment, equals 1.25. All right, is this greater than 1.5? It is not. This is what I like to do, not. Greater than 1.25, or 1.5, and therefore not adequate. Adequate FS? No. And those are our 3 answers. So at this point, what do you have to do? In normal standard conditions, I mean, 99% of the time, 100, almost 100% of the time, this isn't going to go anywhere. You have a 1.5. This wind load is probably your worst case scenario. You're not going to, rarely ever going to see this. You still have 1.25 factor safety, but that's not in the code. You have to follow code. Code is 1.5. So what do you have to do? Well, this is not adequate as it is. You would have to go ahead and put some sort of anchorage into the foundation. You would have to anchor it so it can't, you have to resist that uplift force. And I guess we can go ahead and figure out how much uplift force we have to figure out. And I guess I can get it down here without even having to do any more. So let's go ahead and do that. Let's figure out how much upper to get that 1.5. What are these anchor bolts? And these would be, I'd have a plate right here, and then you'd have these concrete anchors going down a certain length or whatever into the concrete or whatever this is. It doesn't have to be concrete. Whatever the foundation is, so it can resist that uplift. So pretty much what we need to do is we need to get some sort of force like that goes down like this, that it contributes more to this resisting. We really need what? 1.5 times 4. Okay, let's kind of start over. We need factor safety of 1.5. Correct? We know this. And we always said it's resistance over load. We know what our we need to know what our What am I doing here? Let's just think about it logically. I think I'm confusing myself. We need a factor safety of 1.5. Our load is 400, so we need to get... Let me get rid of that FS. Just write this. 1.5 times 400 foot kips. We need 600 to resist this. 600 foot kips. We already have 500 foot kips. So we need an additional 100 foot kips from these anchors. And this moment arm is 20 foot, so we can go ahead and divide that by 20 foot. And we get what? 5 kips. 5 kips for whatever this. And you want to put it on both sides. 5 kips on this side because the wind could switch direction and actually go that way, and you're going to have the same problem. So you're going to want to put... These need to be able to resist 5 kips of uplift. So we can, uplift equals 5 kips that we need to resist. That might be a little confusing, so maybe I'll just get rid of that. But I think you get what I'm trying to say. To get that factor safety of 1.5, we need to put these anchors in that will resist 5 kips. So, who knows what type of building this is. Let's assume that it's here's a quick plan view. And what I would do, when you have an H pile coming in, let's say that's this member right here. These columns are H piles, and I would have a plate that's welded to the plate, or it could be, it doesn't have to be welded to the plate. It would be though, in my estimation. And then you'd have in that plate you'd have 4 anchors. So let's say if you did have 4 anchors, you could have more than 4 anchors, but let's say we have 4. You divide that by 4 anchors, and each anchor would have to 1.25 kips per anchor. So this is how it kind of looks in elevation view. Oh my, that's gross. Okay, there's your H pile, there's your plate, and then you'd have like a hole in these plates. Then you'd have your anchor going down into, this is concrete footing of some sort. This is the concrete footing. This anchor goes down there a certain distance depending on what your anchor needs to be according to your manufacturer. And then you could bolt it, and they put it down, they drop that in, either you drill it and then put it, and then you can put a washer on, and then maybe 2 hex head screws, and you tighten them, and there you go. And when this tries to lift up at any point, it would not be able to, because these would be holding it down. That washer would be holding the plate down, and the plate would be holding the anchor somehow, and the anchor would be holding into the concrete, and you'd be able to account for supposedly a larger footing. Maybe a footing looks like that. Alright, once again, overly simplified, but I do hope it helped you out, and I will see you on the next example.